Okay, here we go. We're trying the same number, number 9 palindrome number. We're going to try to do this fast, because eventually we're going to have to be able to code fast, to be able to do medium problems fast. So, without further ado, we already know what to do, so let's make our whiteboard, and we're going to try to arrive at the same solution without, without converting to a string. So, our function is we'll get this out of the way. There's no need to have pencil and paper. I can't use it anyway right now. Function is palindrome. And the input type is x of type integer. And it will return a boolean. And after we declare the function, we're going to say is palindrome. And then we're going to do a few test cases. Okay, now we'll return true after checking if it's a palindrome. I believe we can x is less than 0, we can return false. Given the constraints that x is an int. We don't have to worry about the idea of the case where it overflows or anything like that. Okay, so we eliminated all negative numbers. Now, we know that x is greater than or equal to 0. Okay, cool. So, let's take our number, 10,001. How do we get the first digit? So we could do this a couple of ways. The thing that I'm thinking about is a two-pass solution. I can't think of any clarifying questions to ask right now because it seems pretty straightforward, given that we know what the constraints are. And we can't convert it to a string. But we could take the modulus of 11,111. X equals 11,111. X mod 10 equals 1. X mod 100 x divided by 10 equals, let's try this, is 1, 2, 3, 4. On pass 1. On pass 2, x divided by x mod 10 equals 4. And on 3, we have x of 1, x of 2 divided by 10 equals 12. X of 2 mod 10 equals 3. And then 4, we have x of 2 mod 10 equals 1. And then x of 3 mod 10 equals 2. Okay, now we have we could build an array deck. Perhaps. At position 1 we have 5, at position 2 we have 4, at position 3 we have 3. At position 4 we have 2. And at position 1 we have 5. Oh, okay. Cool. So we can declare a variable what do we want to call our x temp? We'll call it n. Well, shoot. There's no reason why we can't change this to be called x naught, which is going to make things a lot less confusing for us. Then we can store x as x naught. And x is the current remainder. And then we can say while x is greater than 0, hold on. Yeah, we're okay. Yep, we're okay because we're going from right to left, not left to right. If we were going left to right, we'd be in trouble with trailing zeros. We're going right to left. We always know that there won't be any leading zeros. So, well, x is greater than 0, we'll have a mutable list, value list equals mutable list of type int, and then we'll go ahead and instantiate it as an empty list. Well, x is greater than 0, list add x mod 10 to add the last digit. Okay, now we will do list we will say x equals x divided by 10, do an integer division of x, reassign it to x divided by 10. So, on our first time through, we have 5. So our list contains 5. And x is now 1, 2, 3, 4. On 2, on our second time through, x mod 10 is 4, and the remainder is 1, 2, 3. So we added 4 to the list. Third time through, we add 3 to the list, and we're left with 1, 2. And the fourth time through, we add 4 to the list, and the remainder is 1. The fifth time through, x4 divided by 10 equals 0, which is now going to be the end of the while loop. And x4 mod 10 equals 1. Okay, so now our list will contain 1, 2, 3, 4, 5. And actually, instead of list, Oh. That's fine. Okay, so now we have the list 5, 4, 3, 2, 1. And we can do a for loop I in 0 until, well, no. The length is 5. We want to do 0, 1, and we don't care about 2. So we'll do 0 until length integer division by 2. List length, or list size, yes, thank you, CoderPad. From 1 and 0 until list size divided by 2. Oh. You know what? We probably could have done like a val a equals lists to int array. A size over 2. If a of I is not equal to a of a size minus 1 minus I, return false. Okay, a size is 5. Index of the last digit is 4. Minus 1. Okay. So we checked the first index and the second index, and looks like we're in bounds. Okay, cool. So this solution looks good. It only took us 18 minutes to do. We did it as fast as we could. Bug checking. If x is less than 0, return false. If x not is less than 0, return false. That looks good. Variable x equals x not. X is a variable because it will change because we're reassigning it. Variable value list is a mutable list of int. Well, x is greater than 0. List add. We will add to the list the last digit every time, and then we will divide x by 10 to get to the next digit. Our value a is the array list converted to int array. This will allow us to, it doesn't matter that much in this case, but probably good practice to convert to int array to allow for faster indexing. Although we did assign some more memory. Depends on what we're optimizing for. Which actually on Android app, I mean, memory is usually tighter than speed is, but I digress. Here we are, we added more space complexity. For I in 0 until a size divided by 2. If a of I Okay, so let's see. Our range is I in 0 until a size divided by 2. That looks good. If a at index I is not equal to a at a size minus 1 minus I, we return false. And then after going through his palindrome, we'll return true. Okay, so now we'll try putting in the LeetCode. We're going to paste our solution. We're going to rename x to x naught. And we will run our code and check for syntax errors, which I don't think there will be any, and I'm betting everything on it, betting the farm on there being no errors. Let's run 1, 2, 3, 4, 5. And we'll submit this. We accept it. We got accepted. Okay, yes. Memory usage is higher. Runtime is lower. Runtime is a little slower, but not too bad. Okay, we did all right. It only took us 20 minutes to do. 22 minutes, really. Which is better. So there we are. First LeetCode problem done. Alright, we'll call that good.